Hi, I'm Professor Stephanie Sidlick. I'm a professor in the chemistry department here at Carnegie Mellon University. And this series of videos is going to demonstrate some laboratory techniques that we'll be using in my class this spring. It's a graduate level course. And it is about the molecular basis for polymer mechanical properties. So this first video, it is a series of modules, but in our first video we're going to be talking about air-free synthesis and how you can synthesize a polymer using air-free and water-free techniques. And here in Pittsburgh, this can be especially important in the summer because it's very humid. So the particular polymerization method that we're using is very sensitive to oxygen. And so we want to exclude oxygen because oxygen interferes with the catalyst, and if the catalyst can't work, then we can't grow a full-length polymer. Basically, the amount of care and skill that you put into your synthesis dictates how good of a polymer you get out, which in your research you might imagine if your polymer is behaving really well, it's going to do the things that you want in your project, whereas if you didn't do a good job synthesizing it, it won't have the properties that you expect. So first we'll be demonstrating Schlenk technique, which is this method for air-free synthesis. So what we have here is a Schlenk line, and on this particular Schlenk line, this top tube is under nitrogen. So a positive pressure of an inert gas, nitrogen is being dried and pumped in through that line. And then on the other side, this lower side, we have vacuum. So basically what we're going to do is we're going to take this reaction flask, we'll have it oven dried, so you can put your glassware in an oven and this kind of cooks the water off before you start your reaction. And I'll also show you today another quicker way if you've forgotten to oven dry your glassware. You can use a propane torch to do it. But we won't need to do that for the class. This is just in case you forget to dry your glassware in the lab. So first thing we want to do, when your glassware comes out of the oven, you put in your stir bar and you put on a stopper. After that, we'll hook it up to the Schlenk line. And here in my lab, what we like to use are these syringes that are cut off. It's a little bit makeshift, but I found over the years that it works really well. Okay. And now what we want to do is remove all of the air that is in the flask. And we do this by opening up to the vacuum. And as you open it, you want to open slowly and carefully up here. And you can hear a little bit of a suck as the air leaves the flask. Okay, and this bonus step, again, we won't be doing it in class, but you can take propane and use a propane torch to dry your glassware. And you can see, if you come in really close, as we put our torch up to it, you can see the water actually condensing as it's pulled off. And so you just kind of want to come around until you stop seeing the cloudiness from the water evaporating from the glassware. Now, since you won't have to do that, since your glassware is already dry from water like that, what we'll be doing is evacuating and refilling our flask with nitrogen 3 times. And this will put this under an inert atmosphere. And this is a pretty tricky technique for someone who's doing it for the first time. You have to be pretty careful with the flow of nitrogen, as well as the vacuum, because if you don't do it quite right, the oil here and our bubbler will get sucked up into the Schlenk line. And then that could potentially contaminate all of your experiments with the oil. So you have to take a lot of care, and last year 2 of the 4 groups did suck oil into their Schlenk lines. And that's okay, it's a teaching moment. We then get to take down the whole Schlenk line and learn how to clean a Schlenk line. But your laboratory experiment will go a lot more quickly if you don't have to do that. So the tricks to doing this are, first, to make sure that you turn the nitrogen up. So over here we have a bubbler connected to the positive flow of nitrogen, and this lets you see how much nitrogen is coming out through the system. And so what we do is, right now this is suitable for what we're doing, which is running a reaction. We have the reaction that we're setting up here already going right there. We'll talk about that in a little bit. So we want to turn this up. And we do this with this knob over here, and you very carefully and slowly want to turn it until you see a more steady stream. This is a little bit aggressive, but this will be helpful because essentially, since this is under vacuum, when we open this to nitrogen, it's going to suck the nitrogen, and if we don't have a high flow, that's how the oil will get sucked in. So first, very important, we close our opening to the vacuum for this flask, and then very, very slowly, watching the bubbler. So essentially what you want to be looking at is the bubbler and not your hand. Very slowly, with my hand, I am opening the nitrogen. And you saw that? It sucked up into the line. And what I did was I quickly, as soon as I saw that it was sucking the nitrogen up, I turned it back. So now I'm going to slowly open it again. That first little suck there is enough. Sometimes you get that happening 2 or 3 times depending on how good your vacuum is and how large your flask is. So we'll close that. We have it filled with nitrogen because we can see the flow is there. And now we just open it up to vacuum. And we heard the nice little suck, the release of pressure. And we'll wait a few minutes for the vacuum to clear it out. Close this. And again, we make sure our bubbler is giving us a nice high flow of nitrogen. And very, very slowly we turn this just until we see it come up, and then we quickly close it. And you see that one, I wasn't quite quick enough with it. It went all the way up to there. So you want to be a little slower. We're going to try this again, just to make sure. There we go, that was better. And now we're ready to fill the flask with nitrogen. Okay, the flask is full. We can close that and open it up to vacuum one more time. Give it a few moments there. Close the vacuum. And it looks like the bubbler is slowing down over here, so what I'm going to do is actually turn off the nitrogen. You can't have the nitrogen too high, but you want to be to err on the side of too much nitrogen, if anything, because it's just going to make it easier for you. So there we go. I turned up the nitrogen flow. Pretty aggressive, but again, we want to avoid oil in our lines, so we are going to open up to nitrogen. Make sure our vacuum is closed. That's the last thing you want to do, is have both of these open at the same time. And very carefully and slowly watching this. Flask completely open now, and we have our vessel completely air-free. So that's the trickiest part of today's experiment. From here, we're just going to set up our polymerization, adding in our reagents. For class, you were given a handout that gives your synthesis, and in the past I've gotten complaints that this is not detailed enough. It doesn't say anything about evacuating and refilling 3 times. And this is actually by design. As graduate students, you're going to be getting most of your procedures from papers, and this is what the paper is going to say. And so you need to know how to read a paper and then actually translate it to doing something in the lab. So that's why we're doing this. But here in the paper or in the handout for today, we have descriptions of the reagents that we need to add. So first thing that we want to add, according to the paper, which you will have written out in your lab notebook ahead of time, is monomer. And so today we're going to be making PBMA, polybutyl methacrylate. It is one of the homopolymers, but the copolymers that we're making are synthesized and added in basically exactly the same way. Okay. So I'm adding 11.2 milliliters of this, and we'll do that with a syringe. And just like with all chemicals, you want to never take and put back, once you've taken it into your syringe, it's out of here. So you want to be careful to just take the amount that you want. I took a little bit much. We're looking for 11.2. That's a 12 right there. That's okay because we want to get that air bubble out. So the way we do this is we take a Kim wipe or a paper towel, and up near the needle's tip, being careful to keep your fingers very far away from it, we push that air bubble out very slowly. Air bubbles out, so now we down to 11.2 milliliters. And just add that right into the flask. Perfect. Next, we'll add our abbreviated it as. It's ethyl bromoisobutyrate, and we add just a very small amount of this. And so the procedure calls for 0.055 milliliters. So we're going to measure that out with a 1 ml syringe, and we're going to have to look very closely to get that as precise as we can. Flick it to get the air bubbles out. Grab a Kim wipe. Keeping your fingers away. .55 is right between the 0.5 and the 0.6, so we got that. With this, it's such a small amount, you want to make sure that you're hitting the center of the flask so that it doesn't get stuck on the sidewalls. So put the syringe in, make sure it's far away from the sides, and then inject. Okay. One more reagent right now. This one's a little bit tricky. So it's a solid. So we actually have to very quickly remove the septa to introduce the solid. And this is our copper bromide catalyst. And I've pre-weighed it here. You'll use a balance to weigh it out in class. And now one way that you can do this is if you have a flask with 2 arms. The second arm is the one that you can take the stopper off of while it remains under nitrogen. What we're going to do though is very quickly and carefully remove this stopper and add the catalyst in one shot. And you want to make sure that it doesn't really get stuck on the sidewalls, so you're adding it quickly, but then also evenly to the middle of the flask. So here we go. uneventful. We can see it's back under nitrogen. The nitrogen's bubbling again. And last thing we want to add is solvent. Just 2 milliliters of toluene. Toluene, since it's a solvent, you don't have to be quite so precise with the measurements. It's a bigger bottle, so I'm having, you can see a large amount of air in there. Not ideal, but there we go. We have our 2 milliliters, a little bit of excess, so we'll squirt that onto the chemoid, and the chemoids here then will go into our hazardous waste. And in the toluene goes with the rest of our reagents. And now we're ready to sparge. And so what sparging is bubbling nitrogen through our solution. And we're going to let that go for 10 minutes. So basically what we'll do is we'll take a long needle, and I mentioned this particular polymerization method is sensitive to oxygen. And so we sparge to get rid of dissolved oxygen in our reagents. So what we're trying to do is replace the dissolved oxygen with dissolved nitrogen, which is inert. So first we'll take this out. Replace this with this longer needle, and then we will put it back in to the reaction. We also need to include an outlet, so that there's some release of pressure so that we can see the nitrogen bubbling through here. And we look. Actually see the bubbles, and so there we go. We can see that we have a nice solid bubbling going on there, and this is good. So we're sparging this now, and we're going to let that go for 10 minutes, and then once the 10 minutes are up, we are going to switch back to the shorter needle and put it into our hot bath. And so these are our hot plates. They're digital. This one's already set to 80 degrees C, so perfect. Just what we need. And once that's set up, we'll put that in there. All right. I'm going to let this sparging continue, and we will call it a wrap for day 1. Thanks for watching.